Hello class, today we're going to talk about lesson 4-5, scatter plots. Our objectives are we can create and interpret scatter plots, and we can use trend lines to make predictions. Our first vocabulary alert is scatter plots, which are just a graph with points plotted to show a possible relationship between two sets of data. Our first example is graphing a scatter plot from given data. The table shows the number of species added to the list of endangered and threatened species in the United States during the given years. We have to graph a scatter plot using the given data. Alright, so let's make our graph. There are a few things every good graph needs. First, we need to have a title. We also need to have a label on both our x and our y-axis. So our title, in this case, are the species added to the list. Our x-axis is going to represent our years, and our y-axis is going to represent the number of species that we actually add to each list. So now we're going to actually graph each ordered pair where we have the year as our x-coordinate and the number of species added as our y-coordinate. So our first point is at 1996 on our x-axis and 91 on the y-axis. So let's plot that point. There. Now we're going to also do that for the other points in our table. So let's graph 1997, where there were 79 species added to the list. And then in 1998, we had 62 species added to the list. In 1999, there were 11 species added to the list. In 2000, there were 39 species added to the list. In 2001, we had 10 species added to the list. And then in 2002, we had only 9 species added to the list. So we've graphed the scatter plot. It's just a bunch of points that make a pattern. In fact, that pattern brings us to our next vocabulary alert, which is a correlation, which just describes a relationship between two different sets of data. In fact, there are 3 different types of correlations. There's positive correlations, where both sets of our data values increase, negative correlations where one set of data values increases and the other set decreases, just like in our first example. The years increased, but the number of species added to the list decreased. So that was a negative correlation. And then there is no correlation, where we can't tell if there's a relationship between our two sets of data. So we do need to be able to describe the correlation illustrated by a scatter plot. So to our right, we have a scatter plot which is titled TV Watching and Test Scores, where our x-axis represents the number of hours spent watching TV, and our y-axis represents the test scores. So if we look at the scatter plot, from left to right, as our test scores increase, it looks like the number of hours that we spend watching TV decreases. So if we look and think about the different types of correlations we could have, we want to look at which type of correlation explains when one set of data increases, the other decreases. That looks like it's a negative correlation. So we could say that this scatter plot represents a negative correlation. Another way you can think about how these two sets of data are related is that it's not just when test scores increase, the number of hours spent watching TV is decreasing. You can also think of it as we spend more hours watching TV, our test scores decrease. We have a pattern that goes downhill. The graph, or all the points in our scatter plot, form a pattern where if we drew a line through it, it would go downhill. So that's why the scatter plot represents a negative correlation. Okay, so we also need to be able to identify correlations from sentences or situations. So we need to identify the correlation we would expect to see between each pair of data sets and then explain why we think that. So A, the number of empty seats in a classroom and the number of students seated in the class. So we would expect to see a negative correlation because as the number of students increases, the number of empty seats is going to decrease. Think about when you are coming into class. There's a lot of seats that are open, but as more of your classmates come to class, fewer and fewer seats are available for them to sit in. B, the number of pets a person owns and the number of books that person read last year. Do you really think that the number of pets someone owns is going to determine how many books they read? Well, not really. So we would expect to see that there's no correlation. So the number of pets a person owns has nothing to do with how many books that person is going to read. Now let's look at C, the monthly rainfall and the depth of water in a reservoir. So a reservoir is a place that holds water. If it's going to rain a lot, well, that water or that reservoir is going to have more water in it. So we can expect to see a positive correlation because as more rain falls, there's going to be more water in that reservoir. Alright, so we also need to be able to match a scatter plot to situations. So if we're given 3 different graphs, we need to be able to match it to the situation. So we need to choose a scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. And then we need to explain why. Well, if we look at graph A, this is a positive correlation between the number of days and the height because the plant will grow each day. If we look at graph B, neither the number of days nor the plant height can be negative. And if we look at graph C, this graph shows all positive coordinates and a positive correlation. So it could represent our data sets. I would automatically get rid of graph B because of the fact that we can't have anything be negative. I would also get rid of graph A because knowing what we know about plants, they are going to just continue to grow as time goes along. So we've only got one logical graph left, and that's graph C. So C is the correct scatter plot to our situation. We've got another vocabulary alert. We've got trend lines, which are just lines that help show the correlation between the data sets more clearly. And it can also be helpful when we are making predictions on our data. Alright, so we also need to be able to make predictions with scatter plots. So we have a scatter plot here to the right, and this scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper sold as a school fundraiser. Based on this relationship, we need to predict how much money will be collected when 175 rolls have been sold. So to do that, we need to draw what's called a trend line and use it to make a prediction. When we're drawing this trend line, we want to draw a line that's going to go through most of our data points, but will have equal amount of points above the line as below the line. Alright, so we've drawn our trend line. Now we're going to make our prediction. So we need to predict how much money will be collected when 175 rolls have been sold. So to do that, we're going to start by drawing a line up from our x-axis, where the rolls sold is labeled, all the way up to our trend line at 175 rolls. Now that we've done that, we're going to draw a line over to our axis so we can estimate or predict how much money could be raised if we sold that 175 rolls. In doing this, we can see that when we sell 175 rolls, we could make about $1,200. So that's a pretty good prediction. So that wraps up lesson 4 or 5 on scatter plots and trend lines. What I'd like you to do for your homework is to complete the Your Turn problems for class. See you later.